So today we are continuing on Unit 6. That's really the next big goal, is to get through at least Unit 6, and then we'll kind of evaluate where we are. Last week, when we met last, we focused on some operations with vectors. We're kind of continuing that. Today we're doing something called the dot product. And there are two formulas that you can use to find the dot product. The first one is if we're looking for, essentially we are looking for u times v. One way we can do this is we take u1 times v1 plus u2 times v2. And one thing you want to notice is when you do this, we actually end up with a result is a number, which would be a scalar. So in other words, we don't end up when we multiply two vectors with another vector. The second formula, if remember, this doesn't mean the absolute value of u and the absolute value of v, it means the magnitude of them. So let's break that down a little bit. So this is actually equal to the magnitude of u. And remember, to find the magnitude, it's just using the distance formula or Pythagorean's theorem. So that would be u1 squared plus u2 squared. So in other words, your x component and your y component. To find the magnitude of v, same thing. You've got v1 squared plus v2 squared and taking the square root. And then finally, theta is the angle that's in between those two vectors. Angle in between. Vector u and vector v. And from those, we end up with several additional properties, and I just want to point out really some of these we've seen before. So if you take a look at this one, u times v and v times u, that looks similar to the commutative property. If you've got 0 times a vector, that means you end up with 0. We've seen that before. That is the 0 property, or the multiplication property of 0, which says when you take something and you multiply it by 0, you end up with 0. Okay, let's take a look at this one. You've got u times the sum of two vectors, which is u times vector v, u times vector w. That looks similar to the distributive property. And this one's the same way, only you're distributing in this case on the right side instead of on the left side. So both of those are the distributive. If you take a look at this last one, this one looks similar to the associative property of multiplication. So all of those are also true for vectors as well. And this is probably the only one that I can't really relate it to something that we did under real numbers. But if you've got u times u, you can still go ahead and just multiply it out using this dot product as well, or you can use the shortcut. So let's go take a look at a few examples. We have vector u and vector v, and we want to go ahead and multiply those. So u times v. And I'm going to use that first method here. So I'm going to take my first component here, multiply it by my first component here. So that would be 3 times 6 plus the product of my second components. So that's 18 plus 45, and we end up with 63. Let's take a look at the next one, and again, you can pick either one. I don't have an angle in between it, so I'm going to go ahead and stick with this method right here. Remember, this simply means I've got -1, 5 for the components there, -6, -2 for the components there. So if I'm going to multiply the two vectors, I'm doing exactly what I did here. I'm multiplying the x components, multiplying the y components, and then adding them together. So we've got 6 plus -10. Ultimately, we end up with -4. Okay, moving on to number 3, again, same thing. I don't have that angle in between, so I'm going to stick with that easier method. I've got my components here and here. Again, I'm multiplying the x components, I'm multiplying the y components, and then I'm adding them together. So negative 56, negative 36, and ultimately we get negative 92. Now, if you look at the last one, in this particular case, we do have an angle. So I'm going to, and I don't, if you look at the first method, I'd have to know the components, and I don't know the components. I just have the magnitude. So if you look at your second formula up there, if I'm doing u times v, it says the magnitude of u, magnitude of v times the cosine of the angle in between. So we've got 4 times 10. Cosine of 2/3, 1/3, 2/3. So that would correspond with a negative 1/2. And finally, we end up with negative 20. Okay, continuing on to the back then. It says to go ahead and draw 2 vectors that are perpendicular, and then we want to take a look at their dot product. So first of all, we want to come up with 2 vectors that are perpendicular, so that means we are looking for opposite reciprocal slopes in order for them to be perpendicular. So I'm just going to go ahead and I'm going to start at the origin. I'm going to go up 1 and over 3, and we'll just call that vector u. So we've got vector u has components 3, 1. So vector v, as I said, if this slope is 1/3, one that would be perpendicular is opposite and the reciprocal. So from here, I'm going to go down 3 and over 1. We'll label that to be vector v that has the components 1, negative 3. And we're going to go take a look to see what happens when we do this vector product. So again, we're going to multiply 3 times 1. And we're adding 1 times negative 3. We've got 3 plus negative 3, so notice what happens. You end up with 0. These are considered to be orthogonal. So they are orthogonal if their dot product is equal to 0. And let's just also use using that other formula as well. It's the magnitude of this one times the magnitude of this one. Okay, so if we go and look at the other formula, it was the magnitude of u, magnitude of v times the cosine of the angle in between. So the magnitude of this vector here, 3 squared plus 1 squared, would end up being radical 10 times the magnitude of this vector, 1 squared plus a negative 3 squared ends up being 10 as well. And then you've got the cosine, and we know it's 90 degrees because the vectors are perpendicular. So radical 10 and radical 10 ends up being 10, but the cosine of 90 is 0. So notice again, when you go and look at their dot product, we end up with a product of 0. So again, anytime that product is equal to 0, we end up with the vectors being orthogonal, which is just a fancy word for perpendicular. Okay, so let's take that second formula that we were given. We can actually manipulate it to go and solve for if we're looking for that angle in between. So in other words, if I'm looking for theta, well, first of all, I would have to go and divide by the magnitude of u and the magnitude of v. And then remember, anytime I'm looking for that angle, I would do the inverse. So I've got to find that angle. I have inverse cosine of u times v, which is that dot product, divided by the magnitude of u and the magnitude of v. So let's go get a visual of what's going on in this one. I'm going to sketch out each of these vectors. I have the vector 2, 3. I have the vector -2, 5, and I'm looking for that angle in between them. Now probably we could go and do this potentially on our own, but we're going to go ahead and stick with their formula instead. So we're looking for that angle in between. So take a look, it says inverse cosine, so we want to go find the dot product of those two vectors to begin with. So 2 times -2 plus 3 times 5 divided by the magnitude of each vector. So the magnitude here is 4 squared plus 3 squared, which would end up being radical 13. The magnitude of this vector would be -2 squared plus 5 squared, which ends up being radical 29. So we've got inverse cosine. My numerator simplifies to 11. My denominator is 13 times 29, and I end up with 55.5 degrees. I'm going to pause it and grab my calculator just so I can show you how to enter that in there as well. Okay, first of all, I'm going to go ahead and make sure I'm in the right mode. I'm in degree mode. I'm going to go ahead and do inverse cosine, and I can type in everything that I see. 11 divided by the square root of 13 times 29. Close that, and we again should end up with what we got, 55.5 degrees. Okay, the next one is similar, so I'm going to go ahead and pause, give you a minute to see, really it's similar to this one right here, but give you a minute to work through it yourself. Okay, so I made my sketch, just typing everything in. I'm just double checking. I'm multiplying the x's, multiplying the y's, adding those together. I found the magnitude of the first vector, the magnitude of the second, went ahead and multiplied those out. Eventually plugging that in my calculator, inverse cosine of 1 divided by the square root of 50, I've got 81.9 degrees. Okay, the last set of problems is really just looking at a combination of what we had done the last few lessons with this one right here. And really let's just focus on, with these operations, do we end up with a vector or do we end up with a scalar? So if you take a look at number 9, we already said that when you have the multiplication of two vectors, that ends up being a scalar, meaning just a single number. If you look at the next one, well, this product right here would give me a scalar, which is just a number, times a specific vector. That means we end up with a vector as our final answer. Let's look at this one. Well, this is a number times a vector, so that's still a vector, times a vector, which we said ends up being a scalar, and then a scalar times that vector ends up being, again, another vector. Let's look at the next one. Remember, this doesn't mean absolute value, it means the magnitude. Well, magnitude is a number. Minus 1, again, would end up being just a single number, which again is a scalar. Taking a look at number 17, again, the product of this would be a scalar, this would be a scalar, so a scalar minus a scalar, and again, scalar is just a fancy word for a number, so essentially you have a number minus a number, which again is just going to give you a number, which is a scalar. Okay, again, I'm going to pause, let you look through the remaining ones, and all we're doing here, as I said, just focusing on which is it, a vector or a scalar. Okay, I went ahead and put up your answers on 10 to 18. Let's go and look at 12 and 16 in a little bit more detail. Let's go look at 16 first. So this is 2 minus, and remember, this is the magnitude of u. So I'm taking 2 squared plus 2 squared, which would end up being the square root of 8, and then I could go and type that in my calculator. 2 minus the square root of 8, and I'm ending up with a negative 0.828, which again is a number, a fancy word for a scalar. Let's go look at this one. So I'm going to apply that dot product between these two. So we've got a negative 6 plus 8, and then eventually I'm going to multiply it by vector w. So negative 6 plus 8 is 2. 2 times the following vector. I'm just going to take that scalar and multiply it by each one. Okay, we are done for today. Your Math Excel is up and posted. Just a reminder, it is due by tonight by midnight. If you have any questions or comments, you can go ahead and post those on the discussion board as well. Please let me know if I can help you out in any way. As I said, we really have Unit 6, maybe a little bit of the next unit, and then that will be it. We are on the home stretch. Hang in there. Thanks.